How to set flow estimation with ATV600 on a multi-pump system. Hello. Today we will show you how to program and use the flow estimation function, which helps to manage the pumping systems by estimating and monitoring the flow rate. You can apply this function to a centrifugal pump or any other pump with similar characteristics. This function is most often used in multi-pump systems with a global flow sensor. The goal is to demonstrate the embedded features of Ultivar process ATV600. Flow estimation may be set using the graphic display terminal, SoMove software, or embedded ATV600 web server. In our example, we will use the graphic display terminal. The power versus flow (PQ) curve can be used in both cases if there are or if there aren't inlet-outlet pressure sensors on the system. The head versus flow (HQ) curve can only be used if there are inlet-outlet pressure sensors during the commissioning. In the following example, we will use a multi-pump system. On our system, we have a global flow meter, and we want to estimate the flow rate on each pump. Please refer to the FAQ 000-2420-58 to configure multi-pump function. We will use the head versus flow (HQ) curve because we measure the pump's head using the inlet-outlet sensors installed on the pump during commissioning. Pump characteristic curves must have been programmed for the estimation flow function to be active. Before starting the flow estimation function configuration, you must program the characteristic curves for each pump in the system on the associated drive. Please refer to the video about pump characteristic curves, FAQ 000-2470-33. The curve may be filled and activated in the Pump Functions menu, then Pump Characteristics menu, or Flow Estimation menu. When using the HQ curve in a multi-pump system, you must calibrate each pump individually. To calibrate a pump, you must isolate the pumps that are not being used. Calibration may be done using a global flow meter during commissioning. It will likely be necessary to recalibrate over time, as characteristics of the pumps change during operation. For our example, it is connected to the analog input AI3 and assigned to the system flow value. Calibrate the function with the following parameters. Head dynamic gain, to define a correction gain applied to the estimated pump flow value. Head static offset, to define a correction offset applied to the estimated pump flow value. Liquid density is the density of the fluid to be pumped. RHO is set to 1,000 kilograms per cubic meter in factory settings for water pumping systems. To have access to this setting, change the access level of the drive to Expert. The settings of HEO and HEG are used to calibrate the estimated flow so that it's as close as possible to the real value. Go to Complete Settings, select Pump Functions, then Flow Estimation, and start the drive. For these settings, we need to activate the pump in manual mode at 2 operating points between high speed and low speed. First, at a sufficiently high speed. Here we have chosen the nominal speed of the motor, 48.3 Hz. Set HEG so that the pump flow value reaches the estimated pump flow value. For our example, when HEG is at 17.4%, we have FS2V equal to SLFV. Here, HEG is high because our pump is not new. Second, at a sufficiently low speed. Here we have chosen 13.4 Hertz. Return to the menu, Flow Estimation. Set HEO so that the pump flow value reaches the estimated pump flow value. Stop the drive after calibration is complete. Note, this calibration is related to our system. During your calibration, you will not get the same values. The estimation flow may be used to monitor high flow or low flow without additional flow sensors. Select Pump Monitoring, then Pump Low Flow Monitor. Enable the low flow monitoring by setting Pump LF Monitoring to Flow. In Pump Flow Assign, set Est Pump Flow. Set Pump LF Min level to the value you want to monitor. Here, we set it at 10.0 cubic meters per hour. Set Pump LF Error Resp to define the stop mode of the drive. Here, we set per STT to conform to the common stop mode of the drive. Start the motor at its nominal speed. Simulate a bad flow value by changing the opening value of a bench valve. See that the drive stops the motor when the flow goes under the value of pump LF min level. For example, this can prevent premature pump wear. Thank you for watching. For more information, please visit our website.